very much about modules and packages. Okay, very important concept, because the popularity of the entire Python as a programming language will all revolves around these two things, which is modules and packages. Let's understand what is this modules and what compromise of modules and what compromise of packages. Okay, now, what are modules? Modules, in a simple terminology, will contain the Python definition and statements, which means simply modules is a collection of Python code which contains functions, which can contain the classes, which can contain the data types and all that, and compromise together to create a very organized file that is called as a module. And this module will always end with .py extension, which means to represent that it is a Python related file. Okay, so this Python related file, which has been collected and very neatly organized logically, in the sense there might be a module just to in an application. If it is a web based application, there might be a module which only talks about the user interface, okay, UI part, and there might be a module that can only talk about the handling of data types, handling of database, and there might be a module that can link across for routing and hooks and all that. Okay, and there might be a module very much related to the APIs. Okay, all that what I'm trying to put here is, in simple terms, module is a set of Python related definitions or statements, and they can be like functions, objects, or classes, and all that. Now, the set of these modules, which is if there are more than 10 files, if there are more than one file, then those .py files, the logical collection of those related modules, will be called as a package. Okay, in simple terms, a package can be very much you can say as as a folder location. Okay, in your Windows application, right, there might be a folder which might say this is a mathematical related computation. There is a mathematics or math kind of a folder name you have created. Inside that, there are multiple sub folders that will be calling as the sub packages. Inside that, some modules reside. Now, we'll take that, how to create a module, how to reference that in your program, and how to use them one by one. But for now, just understand module is a collection of finite number of definitions, Python definitions and statements, and these collection of multiple modules will be a package. Now, so as I said, Python also comes up with a standard set of libraries. Okay, a library can be a module. And these modules, like for example, SYS is a module that comes by default built in your standard library. And there is also a standard library module which is called as math. There is also called as CMath, related to the complex numbers. And then there is a random. Okay, random is also a module, and there is statistics module, and all these different kinds of names that I am throwing up now. These are called as Python standard set of libraries or modules. With that being said, as you know, the popularity of Python as a programming language is very much related to the third party tools and packages. Okay, now if you remember, there was, before the class starts, before the initial stages of this lecture, we were talking about Jupyter Notebook installation and all that. Even your Jupyter notebooks can be installed as a package for Python. It's a third party package that can be installed using PIP. We'll come to that, what PIP is and how to install the third party libraries or modules. But just to let you know that even Jupyter Notebook is also a third party package or a library. Now, with that being said, let's understand what are these modules. Okay. And let's go ahead and see. We create one module, okay, for you to understand what it is. Let me go to the folder location where I have this. file that is created. I'm going to use this file. Okay, it is at what, there is a code folder inside that. On my desktop I have created a code folder. Inside that there is Python, and then there is notebook. Inside that this particular ipynb file resides. So I'm going to create inside notebook. Let's go ahead, and this is the location that I was talking about. User skillsam, there is a desktop, then code, Python, and notebook, and this is where my workbook file resides. Let's go ahead and create a folder. Okay, new folder, and this will be my package name. So I'll just name this as my first package. Okay, pkg. So it's simple. I'm creating a folder, and now this will be a package. How is that Python going to recognize this as a package? I'll come to that very soon when I will talk about something called as underscore underscore init.py. We'll come to that very soon. What is that and all. Now, inside this particular folder, I'm going to create another folder which will be called as sub package. Okay, means inside that package, sub package 1. Okay, now I'll create that another folder which is called as sub package 1, and another folder which might say as sub package 2. And inside this sub package 1 folder, I'm going to create a file, and then I'll come to this here. Someone joined. Let me admit them. Okay. So there are two files. Okay. So this is my folder, my package. Inside this my package folder, I have created two folders, which is known as sub package 1, sub package 2. Now, if you observe, what is this folder different from any other folder that we see in our Windows operating system? It's the same, okay? But how is that we are going to let Python know that this is not any ordinary folder, but it is a package? That can only be done using what we call it as, let's say, I have created, this is where I created, right? Inside the fold, and I have created my first package, and there are two folders that I have created. Now inside this first package, what I'm going to create, I'm going to create a very important file which is known as underscore underscore init underscore dot py. Okay, is the very this is always an empty file. Okay, most of the times it is an empty file. You don't have to add anything to this file, but this is the file that will let the Python interpreter tell that the folder that you are currently in is no ordinary folder but a package. This is what underscore underscore init underscore dot py file will let the Python interpreter know that this is a package, Python package. In the same way, how many folders that you create, all the folders need to have the same file. Like I have created this sub package, I'm going to create the same file, underscore underscore init underscore underscore dot py. Okay, this is again, I'm going to create that within this sub package 1, and I'm going to create the same thing inside the sub package 2 as well. So my folder 1 will contain two folders, which is sub package 1 and sub package 2. Each package folder contains the same set of files, which is they are telling the interpreter that they are part of a package, and these files need to be these files can be empty. You don't need to add anything until you want to program it in a different way to script and manual run and other aspects. But now currently we are taking this as a simple example to demonstrate how to create a module and a package. Now, this is my main package location. Inside that, I have sub packages, which can be logically, I can group my programs into this. Now, suppose let's take this package, and here I am going to create a module. Now, what is a module? Module is always a file that ends with .py. So here I'm going to create a module, let's say skillsam.py. Okay. Now, what is this mod? This contains, let's say this is nothing but module by name skillsam for basic basic math computation. I'm just adding a comment. That's it. Now I'm going to create what? I'm going to create certain functions. Okay, let's say. So the for any function, you can go ahead and say, let me increase the font size. Uh, let's go to settings. Try to increase the font size. All right. Now in this, I can go ahead and say define a function. And then inside that, let's say, I'll say add. And this will be num1 comma num2 colon. And here I'll say return num1 plus num2. Simple. So what is this function is going to say? It is the function name is add. It is taking two parameters, number one and number two, and returning the sum of them. This is what the first function is. Suppose there is another function that I want to do, maybe subtract. And here I'm going to do what? I'll do minus. Okay. And then I'm going to do another function, which might say, let's say multiply, MUL. Okay. And then plus will be returned with the asterisk symbol. And then I'm going to create another function which might say div. Okay, so this div is division, and this will be a division. Okay, simple. So what it contains four basic mathematical computation, that is addition, subtraction, multiplication, and division. So this will become part of my module called skillsam.py. And this is where this resides under my package folder, and inside that there is a sub package, and I have created something called as skillsam.py. Now I'll save this. So what I have done now is I have created what you call it as a package and a module. So now the point comes, how am I going to utilize these into my programming? So there are multiple concepts associated with it. Let's see that one by one. Now that you have created this package, okay, and this is what it looks, simple basic computation. Now let's say I'll come to that, how to execute and everything. But for now, so how do you load a module? So the for loading a module into your program that utilizes the module, what you need is a keyword called import. Import will load the built-in or third-party modules into your Python program. So what it does is, let's say there is a keyword called import, and then I need to specify the module name. Module name. Now there are multiple ways to use this import statement. One is called explicit import, and another is called implicit import, as the name suggests. In the explicit import, right, what I'm trying to do, I am trying to explicitly import a particular module. All right. Now for that, what I need to do is just specify import and the module name. Now, as you know, there are a certain set of built-in modules that comes along with the Python interpreter installation. Now, before I'm going to go to the file that we have created, this is a user defined. We have created this module, but there are also certain set of modules that Python itself will be installing as when you are installing the interpreter. All right. So what are those? There are some of them called as math. Math is again one of the module, and there is also a module called random. There is also a module called CMath, which is for complex mathematics. Let's take one example called as random. Simple. So what is this? I am trying to import a module called random. And if I want to see what all the variables and attributes and methods part of this random module, I can do that by using a built-in function called dir and pass the module or the package that is there. If I go ahead and enter, it will give me the list. The list will contain what? It will contain all the variables, attributes, and the methods that are part of that random module. So what you see here is these are the global variables. Okay, underscore underscore, whichever starts is a global variable. Then there are again there are attributes and functions. Like for example, one of them is a random. Okay, so random dot random. So the random module itself contains a function called random. So how do I see that? Let's do that. One way to do is just check the directory or the whatever it contains. Now, how do I access that? What is the way to access a component of the module? It is always by a dot notation, which is first is module name dot, then you get the properties. Now you just enter the tab, you will get all the list of methods that are methods or attributes that are part of this module. Now one of the module that I was function that I was talking about is random. Random dot random. If I go ahead and see what it contains, this will be in the interval of 0 to 1. Whatever the value you pass in, it will generate a random number between 0 and 1, which means it is generating a float number. So let's say if I go ahead and create a random and execute this, it will generate a number like the way we have in JavaScript math.random, right? In the same way, in Python, there is a module called random. It contains a method called random, and this would randomly generate what? Generate a number or a floating point number in particularly that will be between 0 and 1. And if I go ahead and execute it multiple times, this is going to change. What I'm getting it here is, so every time I'm executing it, let's execute, it is 0.07. Now I execute, it is what? 0.75. So this is what the mat.random, I mean a random module you need to execute. So what I have done here is, this is a built-in, okay, this is a built-in standard library or module. Okay, sorry, yeah, library or module. In the same way, there are multiple things. There is also something called as, if I go here, and there is also a import. There is also a built-in standard library called sys. All right, so what it can do is sys. Then there is a method or attribute here called as PS1. So what is this PS1? PS1 is nothing but primary. This is a primary prompt. Okay. So what it says, if I execute this, it will say this is the primary prompt that you are seeing here. This is same as this, what you are seeing input. And there is also another one called as PS2, which is secondary prompt, which is after this. You will see this, you can go ahead and change this as well. Like for example, it was much better understood if I execute it here. You will be able to see in the Python. If I say py, execute the Python code. Now let me import just sys. This is the module, that is a built-in module, system module. Now I am going to say sys module name dot the attribute or the method that is part of that. So there is ps1 is a built-in attribute that will give me the prompt that is there, primary prompt. So what is this? This is a string. The string is this one. You can go ahead and change this as well. Like for example, if your module you have imported, let's say this should be equal to what? Maybe I want to look something like this. Okay, if I go ahead and enter, then my three arrows is changed to this one. Okay, so I can go ahead and see it will remain this one until I exit it, and again I come back, it will be changed to this one. So what I'm trying to tell you here is, you are trying to import a built-in standard library called sys. Inside that there are lot of attributes and methods that becomes part of this library or a module. And here what I just demonstrated you is how to change your primary prompt. And again, there can be a secondary prompt. If I go ahead and see what is the secondary prompt, and that is dot dot dot. Okay, dot dot dot, that you see if you enter multiple lines. All right, so now let me just exit it. So this is what you see. So this is what I did it here, just to demonstrate that there are standard built-in libraries that comes along with the Python installation. Now, let's go ahead. What you did now is explicitly using the import keyword to import the module. That is what we did, explicit module import. All right. Now, there is also explicit module import as alias. Alias is like, for example, you alias is basically you're trying to give it as a separate name to it. Now, suppose there are whenever you create a module, right? Sometimes your module might look very long, like module name itself, like it might be abc dot xyz uh, dot something. Okay, so you can say this module, you are importing this module as some name. You can give some short names for it. One standard usage is like import numpy, okay, as np. So you don't have to use numpy every time. Okay, like in this case, let's take this example as well. So what is this trying to do here? It is trying to import a module called random. Instead of random, I can say every time I need not to write these many 5 keystrokes. I can just say import random as rd, and then for this random I can just say rd. So wherever there is a random reference that I can take, I can just use rd. That's it. This is also will be fine. I'm just making an alias out of it. It is a name that is given to a module called random. So now, with that being said, let's go ahead and see another way that you can explicitly import the module. So the module will contains many attributes or functions in it. Okay, attributes, or for that matter, there might be many things that are part of it. All right. Now, with that case, like for example, there is also an explicit import of content modules. What it means is, now you have seen this. What is that? Let's say import math. Okay. So now this math, dir math. So what it contains so many functions. There is a cos function, sin function. There is a distant function. E is a Euler's constant, that is 2.72 or something. So, and there is a pi is also there, log is there, and these are all constants. Okay, like for example, if I go ahead and say where is that, import dot math, let's say math dot pi. What it gives me the value of a pi, which is 3.142 in short. All right, there is also a math dot e, which will give me the Euler's constant, that is 2.72. Okay, and again, there are a lot of things like math dot uh, sine. Sine might be let's say math dot sine sine 1. Okay, so that will be this one. Okay, the value, the sine theta of 10, or maybe I can give 90. All right, so all this, what I'm trying to give it to you here is a usage of these math modules and their built-in constants, or the attributes, or the methods that are part of this module. Now suppose I want to only use in my function, in my current program, only 3 values. Okay, I don't want to use the entire math module itself. Like you just saw, right? It contains so many things. I don't want to use all of them in order to create a confusion in my program, where there might be a match with the same name. Okay, like some might be the same in this as well as in numpy, so I don't want to collide with them. So in that case, what I want to do is I am explicitly importing certain contents of this module, which is done by import math. Okay, then what is that I am going to import? So I am going to import only these three variable these three properties that at a part of this. Okay, now what I'm going to do is So let's say I'm importing what? Pi, or I'm importing sine value, or maybe cos value, and then e. So what is that I'm importing from? From is another keyword that will specify from what module or package that I am trying to import. From module math, I am importing only these four properties. Okay, so now in this case, I can only utilize these things, and I can say, I can go ahead and execute it. All right, so this is absolutely fine. This is giving this value, this is giving this is the latest value that is printing. If I remove this, it will print this, and if I remove this, it will print only pi value. All right, so this is also what we call it as implicit import usage, but for a particular content. So you are only using a particular contents of the module. All right, now what is implicit? Implicit is when you are trying to say the entire module contents I need. Okay, so what for that, what is the way you want to do it? So the same thing what I can do is, from math import star. The star represents everything. That is what you see. From math importing star, which means this is implicit import. You are importing everything, everything in the sense every module definition or the statements that are there as a part of this module called math, everything that I am trying to import here. So here you can go ahead and do that, but like I said, what is the shortcoming of this? The shortcoming of this would be that whatever the names that are part of this, like for example, if you see here, dir, let's say math. Okay, now what it contains, this math contains lot of properties, and in that one of them is definitely you are going to have there is a way that I can go ahead and use something called as sum. Okay, sum is part of this. All right, so but if you see from numpy, let's say let me use this. Okay, sum, then I'm going to say 10. So yeah, this is an object, right? That, and I can go ahead and say range 10. Okay, so now in the range 10 that I am going to sum it up. Okay, so starting from 2, or if I can say, let's say some range will be a 5. So what range 5 will contains? Let's say range 5 will contain what? It contains 0, it contains 1, it contains 2, 3, 4, 5. 4. It won't contain 5 because that is not the part of range function. Range method will only give you these numbers. And if you sum these numbers, what is this? 3 plus 3, 6, 6 plus 4, 10, and 10 plus 2 is 12. Okay. And if I give this as minus 1, so what it will be? It will do minus 1 of it. So minus 1, so which contains 5 plus 4, which will be 9. And that is what it is showing. This is one way. Now, there is also in your program, there might be a chance that you are also using the same another module called NumPy. And you are trying to do what? You are also trying to import everything from here. All right. Now, there is also a built-in method in NumPy by the same name. Okay, by the same name called sum. And if I give the same thing inside it, it will generate me a different value. It will not give me this. Okay, it will generate me a 10 value, but here it is generating me 9 value. So what I'm trying to say here is, because the usage of these two functions or methods are slightly different, but when you are trying to import everything from this module, at that point in time when you are doing it implicitly everything, these are the challenges that you might face. So ideally you are not encouraged to do implicit import of the module. That is not encouraged. What is encouraged is you try to utilize only what is needed in your program. Okay, like for the explicit import of the functions. All right. So now, with that understanding, let's go ahead and try to see what is that we are going to do. Yeah, again, I was talking about standard libraries, right? So there are many standard libraries that comes pre-installed whenever you install a Python interpreter. Like one module we saw is sys. Okay, sys OS and sys tools for interacting with operating system and including the navigation of the directories and execution cell commands. That is fine. So math and cmath for functions and operations on real and complex numbers. So math is for real numbers, C is for complex numbers. All right. And again, a random we saw just now for generating a random numbers. Okay. There is also func tools, and also iterating for the iterating purposes, right? There is also called iterate tools as well. This is also a module built in standard library, we call it as. Okay. So whenever you say library is whenever you say it is a module that is part of the standard Python. That is when we say it as a library. But most of the time, library and modules, you can use it interchangeably. All right. Now, so far you have understood a lot about modules. Okay. Now let's talk about a package. Okay. And also let's do one more thing. This is all about a standard, right? Let's go ahead and see what we can do in terms of user defined. We have already created a file called skillsam.py, right? We'll talk about that the moment we go to this particular module, which is called as packages. Let's understand packages, and then we'll take up that example. So package, as I said, it is related to the collection of modules, which is called a package. And it is always represented by a dot representation. Okay, we call it as package name dot module name. Okay, this is what we can go ahead and see. And these dot can be chained with multiple folders. If you have a package which contains a sub package and then contains a sub package, you need to chain them by a dot. Okay. Now, how do you access that? Let's see this. Now there is also called as from. All right, like the way that we did. Let's see. If you see here, oh, where is that? Yeah, let me give the example itself. From, and there is a package that we have created, my first package. Okay, dot. This also contains another sub package which is known as um this one, my sub package. All right, sub package 1. From this package, import what module? Module called skillsam. What I'm trying to do here, from the package, this is my main folder. Inside that there is a folder called sub package 1, and inside this sub package there is a module called as skillsam. So from this package I'm importing the module, and then I can say there are what this module contains. This module contains multiple functions, and I'm going to use these functions. Let's say that. So what is that I can do? Skillsam dot add, and then I'm going to pass a value, and this value I'm going to say store it in result 1, and then print result 1. Let's say result 1. All right, now I'll execute it. So what we did just now is we have created a package, we have created a module, and inside the module we have created our user defined functions, and now we have accessed them through a program. Okay, through a simple Python code. So what is done here? So from package, I have imported a module called skillsam.py, and inside that skillsam I have a function or a method that is defined called as add. It takes two parameters. I have passed two parameters, num1 and num2, that you can see here, num1 and num2, and this will return what? The sum of both the numbers. So this has returned me a result, and that result is 12 plus 12 is 24. In the same way, I can go ahead and say skillsam dot, and if I press the tab key, right, it is going to show me what all is there as a part of that. Add is there, division is there, multiplication is there, subtraction is there. So I can go ahead and say, let's me take multiplication. Okay, multiplication of, let's say, 12 comma 12, 12 12 are 144. All right, so now I'm going to store that under result 2. Result 2 will be what? It will take two parameters. These are the parameters that it will have: multiply num1 num2. It is going to multiply and return me that value. So this will return me what? This will be, if I go ahead and, let's say, if I print it 2, then it is going to give me 144, because 12 into 12 is 144. So now this is a very important concept in related to the packages and modules, and this you are going to use it left, right, and center. So it is hugely used in the Python world, because Python's popularity is directly dependent on the popularity of the packages itself. There are many packages that we can talk about. Like there are packages called NumPy, which is for working on arrays and mathematical computations. There is also a package called as Pandas, very famous packages. Okay, and then there is a package called Matplotlib. Okay, Matplotlib, and again there is also a package called Plotly. These are all very famous in terms of Python related packages. Okay, now if you remember the very first session itself, right, we talked about this. If you see here, where is that? Yeah, in the introduction itself, we saw that, right? So if you remember this one, NumPy provides the most of the Python code is scientific computations, and data science is built around the mature and useful packages. Okay, so these are packages that are already very widely used in the Python world. That is NumPy, which is for efficient storage and computation of multidimensional arrays, and there is also a SciPy, which is basically an array of multiple, numerical tools for numerical integration and interpolation. Pandas, as I said, it is for data frame object, and also for manipulate, filter the data transform. All right, and Matplotlib is for what? Plotting the figures and graphs, that you can go ahead and do that. And scikit-learn, this is for machine learning, very famous for machine learning. And as we are already using IPython and Jupyter, very very famous for your interactive notebook environments. Okay, so these are some of the very widely used Python related packages and modules. Now, if I also want to show you one interesting thing here, what is related to. Yeah, let me open that folder. Yeah, now if you see, wherever you have, if I want you to go to a particular folder location in your folder where you have installed Python. Okay, I have installed Python in where? In my drive, inside the installed folder. Inside that, I have created a folder called Python, where my Python is actually installed. Okay, this folder will contain a subfolder called lib, L capital LIB, and inside that, what you see here is a set of modules. Like for example, that I was talking about one module, right? What was the module that I was talking about? Yeah, just now we entered. There is a module related. Again, there is a socket module is there. Yeah, random module. We used the import random, right? This is the module. If I go ahead and open that in Visual Studio Code, this is how the standard built-in module would look like. what it contains. This, triple quotes is for multi-line comments. Okay, this is what multi-line comment would be. And this has been a random variable generators. This is the module. Okay, and this module contains lot of functions. Like what function we used a function called method called as random, right? RANDOM. Yeah, this is the one. We have created this random class, and inside that it has generated as a random number between 0 and 1. Okay, that entire thing is coded here. Okay, it is all written in Python. If you see random.py, this is the module that we were talking about. All right, it has got a lot of code, that a lot of functions that we have seen. All right, and random, range, random. So there are again multiple methods that are part of that random module. Like what is that? Let me import random dir. So if you see here, right, these are again many of them. One is random range. Again, random range is there. If I go ahead and find random range, you can see, yeah, this is the definition of the random range function. It is taking the self, and there is a start position, there is a stop position. These are the parameters that it is expecting, this function. Okay, random range function. So what it contains is, it if you see random range function, right, I'm just trying to demonstrate to you the built-in modules. Okay, random dot random range. And if I'm going to give the random range, right, so I can go ahead and say, generate me a number between 1 and 100. Okay, so what it does is, between 1 and 100, it will always generate me a number. Okay, so now if you give 12, now it is giving me 62, and then it is 15, so so on and so forth. This is what the function is. And if I go ahead and see what it contains, this is what it contains. I have just typing what, shift tab. Okay, go to the parenthesis and shift tab, it will give you the help. So what it is, choose a random item number range. It is giving start and stop, and there is a step. If you want to give a step, you can give, it will skip that particular things. Okay, so this is what the random range method, which is part of the random.py module. This is a standard built-in random module. Okay, all right, then how it is executing and generating that, the entire code resides here, and that you can check it where, inside the folder wherever you have installed Python, a folder called lib, and here you will have a Python file called random. All right, so do you guys understand this? All right, so now again, there is also third party libraries, right? Wherever you have installed the packages, that resides under lib. Inside that, there is a folder called site packages. Okay, go to site packages. Here you will get the third party libraries that you have installed. Like one standard example I can give is Jupyter Notebooks. Okay, Jupyter Notebooks that we have installed, it resides here. All right, and then there is also, we have installed something called as NumPy. There is that n numpy, yeah, NumPy. So NumPy is also a third party library that is installed. All right, so again, a lot of things that you can do and understand, and how it is coded and everything, you can go ahead and refer for yourself and see the code for you to understand. All right, so now with that being said, any questions you have, guys, in terms of packages and modules? Now again, I can, for this, right, import package, from package, I'm importing skillsam. I can name it as alias as well as sg. Again, I can go ahead and use sg instead of skillsam. That is also fine. It is again, you are trying to utilize that as a short notation. Okay, that will also execute the same thing. Or I can say, this one, dot import star. So what it contains, I am trying to import the entire package, sub package dot skillsam. I'm importing everything. So here I need not go ahead and give sg. I can simply say add and multiply. That's it. I don't have to give the module dot something. I can directly use them as a function or a method if I give star. All right. Make sense, guys? All right. With that being said, let's jump on to another topic called as errors and omissions. Okay. There are errors and exceptions. So, what are these like for any programmer, right? Capturing the errors and understanding the errors are is of utmost importance because every developer that codes have to do the unit testing as well. Unit testing is a very important period for a developer as well because only then, when he codes and unit tests it, only then it is moved to the next phase of the development life cycle, which is for system integration testing or integrations testing or a UAT, user acceptance testing. That will go further, but testing is important. Whenever you write even a single line of code, that need to be unit tested by the developer himself or herself. Okay, now what kind of errors that you face? There are multiple errors. Okay, because any programming language, right, any programming language, when you try to write a code, write a piece of code, what you will face, you will face something called as syntax. Okay, there is a syntax, there is a proper structure of the program that you need to follow. There are certain keywords, there are certain the way that you have to name an identifier or a variable name or a function name, and that is all related to the syntax, that is the structure of the program. And also there is also something known as semantic of the program. Okay, so semantic is related to the meaning. Okay, meaning of the program. Like for example, if you want to compute a square of two numbers, you need to take two numbers, you need to use exponential operator like asterisk asterisk and give the square of those numbers. Okay, that is something that you need to figure it out logically and structure the program. So that is all related to the logic and the meaning of a program. So if you fall somewhere short of the syntax itself, like for example, instead of, let's say, um, variable, let's say you have variable name is equal to variable name 1 is equal to, let's say you have created skillsam. Okay, now I'm trying to print it. Now what has happened, there is a single double quote I have given, I have not closed it. This is related to the syntax of how you need to define a variable. So that is the reason the program, the interpreter is throwing me an error saying syntax error, end of line, while scanning the string literal. So string literal, I am defining it, but at the line 4, 1, 2, 3, and 4, at the line 4, this error has occurred because it is also pointing at the exact location where the error has occurred. Now let's say I want to end it here. So now what has happened? Again, there is an error. What is that? Even though I have double quotes and there is a single quote. Now it is saying end of line while scanning the string literal, which means when you start a string with a double quotes, it has to end with a double quote. Okay, only then it is a valid syntax in Python. So if the syntax is not correct, okay, then what will happen? This is called as syntax errors. Now, just now, what you have observed, what I was expecting here is to print skillsam, but here, what I have done, I have misspelled it. Okay, this is what this might not be captured by the interpreter itself because syntactically this is absolutely fine, but what you are expecting as an output, I wanted to I'm expecting a skillsam, but your input itself is wrong. This is kind of a logical errors where you don't know, you are expecting something but you are not getting that output. Okay, these are very hard to find kind of uh, problems because the interpreter will not throw an error but the output is still wrong. Okay, these are called as semantic errors or the errors which are related to the logic of the program. Okay, this is just a simple thing that I have stated. But sometimes what will happen is you have a multiple calculations. Okay, do math is equal to, now I want to do 12 star 12 plus 10 minus 25. Okay, now you have executed this. Okay, now I am trying to print to math. Okay, now what is it throwing? It is throwing me an output of 141. But here there is something wrong with the expression. I was not expecting this. The expression is doing something wrong, because what I wanted to do, I don't want this and this to be multiplied. I want this to be summed up first and then multiplied by 12. Okay, so this plus this, what is this? It will happen. So this is 23 minus 25 will give you me minus 2, and this will return me minus 24. So just imagine the value completely changed from 144 or whatever the value was earlier existing it to minus 24. But my output, what I was expecting, was completely different from what it has given me earlier. So these kind of errors, they are very much not the problem with the syntax, but they are problem with semantics. These are called errors in logic. Okay, the code executes without any problem, that's what we saw, but the result is what you are expecting is totally different. Okay, these errors are very hard to find in the program. That is where you need to debug and see where exactly the value is getting changed. Okay, so this is the very tough part of finding the errors. Syntax errors are the most easiest ones, because the system itself will throw you an interactive message that you can read and check the line number, and you can fix them very easily. And the next set of errors, what we call it as a runtime errors. The errors are syntactically very much valid, but when you execute them, right, then there is a problem. Okay, now one standard and very classic example for this is, let's say, two division. Now what I wanted to do is 22 by 0. Okay, the moment I run it, so what is happening? This has given me an error, because 22 divided by 0 is division by 0 error, which is division, zero division error. These kind of errors, there is no problem with the syntax is absolutely fine. You are able to run it, because what is being done here is you have given the user input is something that is at fault. Like for example, had it been something like this, input 1 is equal to input, and then I'll say enter the n numerator, enter the numerator. All right, and then input 2 is equal to input, and I'm trying to say enter the denominator. Okay, now I'm taking the numerator, I'm taking the denominator from the user. Now what will be here? Input 1 divided by input 2. All right, this is what my simple division operation is. Let me execute this. So now what I am doing, I am putting some value, input, enter the number, and next for the denominator, the user has entered 0. Now till this point, the program is absolutely fine with the syntax. There is no problem. Okay, so the, which means your syntax is fine and your logic is completely fine, and it is going to the right direction where you have pointed it to. But the user is very smart enough to enter 0 now. So what will happen? The moment I hit enter, this will throw an error. These kind of errors are called as runtime errors. They are not captured. They are absolutely fine. The errors are syntactically valid, and fails to execute perhaps due to the invalid user input. Okay, these also need to be fixed properly. So understood, guys, how there is a difference, like a syntax error, the runtime error, and the semantic or the errors in logic. Make sense?
Yes, sir.